Happy Friday. Happy Friday again, right? 3-day weekend. No school Monday. So let's go over this. I want to see some of your answers. Let me see some of your answers. Now, I wanted you to be specific. I wanted you to be specific and not just say, oh, it turns and it kind of changes. I wanted you to tell me, how it changes, right? Oh, sorry about that. I wanted you to tell me like how it changes. And so let's see what you guys said. So, technical difficulties. I got to do it here. There we go. Period 14. Where are you? There you are. Come on. There we go, I think. Okay, so here's what I see. So what your warm-up was to look at this, right? To look at this picture. Uh-oh. Don't worry about that. So look at this picture and tell me what's going on. Can you give me specifically what's going on? Because yesterday you gave me a general answer. You told me, oh, it's rotating, or some of you thought it was reflecting, but it wasn't reflecting, right? So he's rotating. He went 90 degrees, 180 degrees, 270 degrees, 360 degrees. And so you gave me those basic answers. But today I wanted you to be a little more specific. Because we actually got some points. We looked at his thumb and we saw 4, -2. And then when we rotated 90 degrees, we saw 2, 4. Rotated another 90 degrees, we saw -4, 2. Rotated another 90 degrees, -2, -4. And yesterday we came up with general. We're like, oh yeah, they look like the same numbers, and sometimes they switch and sometimes the signs change. And today what I wanted you to do was, can you see the actual pattern? Can you describe what's actually happening? Not in general, like, oh yeah, it switches and sometimes the sign changes. Could you be more specific? And that's what the warm-up was. Now, if you're not that specific, that's fine. Maybe all of us let's pretend this is a crime scene, right? And make sure maybe all of us are detectives there and we're all talking to each other, and that's what everyone's saying here. So maybe people say stuff here, and we can piece it all together and come up with some type of rule, because that's what we do in math. We look at stuff, we observe. This is what math is all about. This is how it all started way, way, way back when people, right, no one invented math. It was discovered because it's always there. People would sit around and you notice things. And you notice patterns, and then you say, this keeps on happening over and over and over again. And then you come up with a rule for what's going on. And then you use that rule. Sometimes it turns into an equation. Sometimes it just turns into a rule that you use for something to happen. And you use that rule every time. So now you don't have to guess. You actually have a rule in writing as to what's going on. So let's see if we can come up with the rule to what's going on when I rotate 90 degrees. What happens to those numbers? When I rotate 180 degrees? When I rotate 270 degrees. Those are the big ones we're going to look at. Now, we know what happens when you rotate 360. It just stays the same. Okay, just stays the same. So let's see what you guys said. As Mario rotates counterclockwise, good, the value and location of the points changes. Yes, we know that. Mario is moving counterclockwise from 360, 180, 90, and 270. Yes, these are all facts that we said yesterday. What I wanted from you was more specific, but it's okay. So we just basically, that person recapped it for us, right? We're rotating 90, 180, 270, and 360, and we're going counterclockwise. And the points change, but they kind of look similar, don't they? So that's what I'm trying to pinpoint. Okay, that's fine. We're all standing in the room. We're trying to figure out this crime scene. Let's see what the next detective says. The points are changing. Okay, yes, they are. Yes, they are. It's kind of like we're in the crime scene and the detective goes, well, there's blood here. Okay, yep, yes, there is blood here. Yes, and somebody's on the floor, injured or... So, yes, you're stating the obvious. Good job. Sometimes we need to do that, right? The points that were made on his thumb are called fixed points, which is the center of rotation. Not necessarily. The center of rotation we're going to talk about is the place where, if you think about if I'm holding Mario on a string, it's the place where I put my finger to hold down the string, so that way the other side of the string can rotate around. So Mario is on this side of the string that's rotating. The center is where I'm holding my finger. So we weren't holding our finger on his thumb, because if we were holding our finger down on his thumb, if that was the center of rotation, his thumb would stay on the same point. But his thumb is also moving. The entire Mario is moving, right? So the center of rotation is not on Mario. right? If it was on Mario, let's see here. If the center of rotation was on Mario, that means I would put center of rotation means that's the one that doesn't move, and then everything else moves. And oops, you can't see that. So he would rotate like that, and the thumb wouldn't move at all, and it would be a fixed point. That's perfectly, but that's not what's happening here, right? The whole thing is rotating like this, right? The whole Mario. So that means I'm holding a string somewhere like right here in the middle, and he's going around. Oops, he's going around that string, that center. But that I like that. I like that. That's a good guess. So yeah, fixed points. The fixed points are the ones that don't move. His thumb is not a fixed point because it actually is moving. His thumb is here. Now it's over here. Now it's over here. The whole thing is moving. And a little hint, the center of rotation is right there. So imagine this on a string, and then we just rotate all. Oops, you can't see me. Okay. This is your center of rotation. And imagine a string on Mario and him going round and round, right, with that string. Okay. All right. As the figure rotates counterclockwise, it rotates around the fixed point. Yes, it does. But the thumb is not the fixed point. The fixed point is that center, which in this case is the origin. We'll talk more about that later. Based on yesterday, he had the same points, but it's reflected, not reflected, right? We weren't reflecting. This is rotation. Reflecting, he would be flipped over the other way and facing, like if we were reflecting, his nose that's facing this way, his nose would actually be facing this way if he flipped over, right? So it wasn't a flip. This was a rotation. But that's okay. There is two mirrors on the X or Y axis. So no, that's not what we talked about yesterday. This is not a reflection. This is not a reflection. Reflection means it would be flipped. So everything over here would be upside or would be backwards, right? And then back over here, that would be backwards. So we're not flipping here. We're not flipping here. But I see how you can see that it might be. But we determined yesterday it wasn't. This is rotations now. We're getting the actual same guy, and he's just rotating. Okay, these are good guesses, and this is why we need to talk about this. This is why we have these discussions, right? This is perfect, right? Wrong is not bad. Wrong is not bad. It's what you're thinking at the time, and then we talk about it, and you go, oh, okay, I was confused, and oh, okay, I got it confused with the other thing. That's perfectly fine to be wrong. I like wrong. I love wrong answers. I'm wrong all the time. Each time he moves, it is a different position, and the way he moves is going counterclockwise. Perfectly, yes, that's exactly what's happening. When Mario is rotating, the points don't change. They stay the same on the same coordinate numbers 2 and 4. So yes, we noticed that, right? All of these stay 2 and 4. But some of them are negative, some of them are positive. The 2 and 4 changes position. So that's what I wanted to see. Can you see the pattern? What's going on? When I went from here to here, how did they change? We know they're changing. That's obvious. We said that yesterday. How are they changing? And some of you are like, Mister, I don't know. Okay, that's what I wanted to see. If you could see the pattern. If you can't, it's okay. We will talk about it. Someone else says they are reflecting. No, they're not. This is not a reflection. This is a rotation. They're reflecting over the y-axis and x-axis, but there is also something else, which is that the points flip every time it is rotated. So if I go from here to here, the x and y flipped, change places, right? The 2 and the 4 change places, but one of them changed signs. When I go from here to here, the 2 and the 4 change places again, and then one of them changed signs. When I go from here to here, the 2 of these flip places, and one of them change signs. And if I go from here to here, the 2 of these change places, and one of them changes signs. So you're right. So when you were wrong about that they're reflecting, right? This is a rotation. But you were correct when you said the points flip every time it is rotated 90 degrees. Every time you rotate 90 degrees, these flip. The X and Y trade places, but one of them changes signs. Okay, so you're on the right path. So again, us detectives were looking over this crime scene, this Mario crime scene. Mario's not dead. Don't worry. He's just there, and we're trying to figure out what happened to him. He just keeps rotating. We're getting closer. Okay, they flip, and one sign changes. Okay. When we rotate 90 degrees, these flip, and okay. This is the figuring out phase. This is the figuring out phase. His hand put up the same direction and have the same number, but each other, like -2, -4, put in positive. Yeah, so you're right. So again, the same thing. These are the same numbers, but sometimes it's positive, sometimes it's negative. They are reflecting. No, they are not. It's okay. If you say they are reflecting, just remember these aren't reflecting. Reflecting means I would flip it over and he'd be facing the other direction. And if you look here, he's facing the same direction. His eyes are this way. His eyes are this way, right? If he was flipped, his eyes are this way. This one, his eyes should be this way, right? Or this way. Okay, so it's not a reflection. As he rotates, his right hand begins to intersect at points that hold the same numbers. Can't really explain it well. Okay. So some of you are like, I can't explain it, mister. That's fine. But you see it though, right? You see there's something going on, but you can't explain it. I understand that. And that's perfectly fine. That's why I'm not mad at these answers. I'm not mad at these answers at all. I like I like the last person's honesty though. Can't really explain it well, but you see something's going on, but you can't explain what's going on. So we'll get to that. As Mario rotates, the points changes within the same numbers, changing negative and positive. Okay, we've been saying that. When he is rotating, he is basically going through the same points, but negative and positive. To me, it looks like he's rotating and is going counterclockwise. That's exactly what he's doing. The numbers reverse and go negative and positive. Okay, I think it means how the point rotates on each side of the graph, and then he rotated to the negative side. Okay, so what I get from these answers is, first of all, he's not he's not reflecting. Okay, he wasn't reflecting. Excuse me, sorry about that. Let me get some water. Okay, sorry about that. So he isn't reflecting, he's rotating. If he was reflecting, he'd be flipping the other way. And he's not. He's still facing the same direction. That's why when I go all the way around, he's still in the same spot. Okay, but you do notice, what I do notice about all your answers, you do notice something's going on here. So here's what I would do. And here's what we are going to do. I would pick a different point on Mario that has different numbers. Okay? And so I want to pick numbers that don't have 4s or 2s because I want to get away from that. So what we did in first period, we found another point right here on his left boot, right in the middle of his, well, not in the middle, but towards the front of his left boot. And we chose that point because it's on the numbers, and it's kind of on, if you look at this one, it's 3, -6, right? If you look here, the coordinates of that point are forward 3, down 6, right? Forward 3, down 6. Okay, so we're looking at this point on his boot. So let's go over here on his boot, do the same point on his left boot, right here, and right there it is, if you look here, it's 6 on the x-axis, then up 3. So it's 6, 3. All right, let's go to this Mario. Let's look at the same boot. The same boot, the same point. And if we look here, that point is backwards 3, up 6. So backwards 3, up 6. And then let's go to this Mario, the same place on his boot. If we look, it's backwards 6, down 3. Backwards 6, down 3. Backwards 6, down 3. Okay, so that's a new point. So I did a purple point. Now, if we look here at his boot, what do you notice about the purple points? Is the same thing happening as with the red points? Right? We picked the same spot on his boot and we followed it along all 4 Marios and look at the coordinates. Are the same things happening? Hello? Is anyone listening?
Bueller. Bueller.
Anyone listening? Anyone listening? Look at the purple points. Are they doing the same thing? Are they doing something different? Same thing, right? If you look at this, they're doing the same thing. But in this case, they're 3s and 6s. I got 3 and 3, -6, 6, +6, +3, -3, +6, -6, -3. They're doing the same thing. And every time I rotate, they flip, right? The 3 and the 6 switch places, and one turns opposite sign. Go from here to here. They both switch places. One turns the opposite sign. So this is telling me there is definitely a pattern. there's definitely a pattern going on. What that pattern is, some of you, it looks like you can't explain it, but you do see it. And that's a big key. You see something happening. Let's generalize it. Let's figure out what can happen. Let's figure out what it is. So let's continue our notes. So yesterday, we defined a rotation. A rotation is a turn around a fixed point called the center of rotation. And someone put that in their answer today, and that was great. Okay, so if we look at our picture of Mario, the center of rotation, my center of rotation is right here, right in the middle. Okay, the origin. And that's what we're going to be focusing on. We're going to be focusing on rotating figures, and we're going to rotate them where the center of rotation is the origin, meaning imagine a string. Right? Imagine a string is put onto that point, and then I hold my finger here. I put my finger here in the center because that's where I hold it, and then I put a string to Mario, and then I just start moving Mario in a circular direction. And so now Mario gets moved in a circular direction. He gets moved over here, and the string is still there. And look at that string. Look at the string. Don't you see 90 degrees there on that string? Ah. Right? So that's how you have to imagine it. Your center of rotation is where you put your finger down on the string. One end of the string is on the center where you hold it down with your finger. The other string, part of the string, goes on the actual figure. In this case, we'll put it on Mario's thumb. And then we swing Mario around in a circular motion. And now he's here. The string's still there. And it's a 90-degree angle that we formed between the two strings. See that when I flip it over? Okay? So that's what we're doing. You got to imagine the center of rotation is where you put your finger down with that string. Okay. So center of rotation, and our center of rotation is going to be the origin. We said that right here. The origin is going to be our center of rotation. It's going to be in the middle. It just makes things easier for right now, especially since we're beginning. And the figure has to rotate. We need two pieces of information. We need two pieces of information when, how we're going to rotate. We need the angle. And what angles are we going to use? We're going to use 90 degrees, 180 degrees, and 270. Okay. Somebody said first period, Mister, what about 360? Well, I mean, you could say 360 degrees, but that just means your figure is back where it started, right? Back where it started, so the point didn't change at all. So, I mean, you can rotate it 360, but that's just, it's back in the same spot. And then what direction are we going? We're usually going to go counterclockwise. If it says clockwise, we're going to change it to counterclockwise because that's the direction we want to go. Okay, so that's what we learned yesterday. So now, can we make a generalization? Can we make a rule? Right? So over here, we're going to say, what's the rule when we move a figure 90 degrees counterclockwise? So let's look. When we just move it 90 degrees. So let's look at the red point. What happened? Explain to me what happened to the X and Y. If you go over here and you go over here, what happened? What's the first thing that you notice that happened? And you guys have said it. You guys said it in the warm-up. What happens? When I move 90 degrees, so from here to here is just 90 degrees, the X and Y switch places. Okay, so let's write that down. And this happens to every point because it happened with the shoe too, didn't it? If we look at the shoe, same thing happened. The X and the Y swapped places. Don't worry about the sign right now. We'll look at the sign. But the X and the Y, the 3 and the 6, flipped places. The 4 and the 2 switch places. So that's the first thing we're going to say in our rule. For each point, the X and Y coordinates switch places, and something else happens. Let's see what else happens. So not only do they switch places, but look what happens. What happened to the 2? What happened to the negative 2? This former Y, now it's in the front, but this old Y goes to be the X, but it turns opposite. And this one stayed the same. But this old Y coordinate turned opposite. If you look over here at the purple, at the boot, look at the old Y coordinate, negative 6. Negative 6 turned into positive 6. So the old Y coordinate, the old Y coordinate turns to the opposite sign. And this one just stays the same. That x coordinate stays the same. So not only do they flip, but the old y coordinate changes signs. So we can put that here too. And we'll put the original y coordinate changes signs. Okay, so for each point, the x and y flip, and then the original y coordinate changes signs. Mister, yes. That's a lot of words. Is there a shorter way? Is there a shorter way you could show this? I'm glad you asked. Yes, there is. Let me show you how we can do this in a shorthand way. So we can say xy, kind of like we did with translations. xy, and I'm going to put a long arrow, and this arrow means changes to. And so how does it change? Well, the y and the x switch places, right? The y and the x switch places, and that y, right? This y right here, this whatever number that is that's now right here, turns opposite. So how do I show opposite in math? I put a negative sign. So when I rotate 90 degrees counterclockwise, the x and y switch places, and then the original y turns opposite. So I'll give you a second to copy that down. Okay, if you have any questions, that's what we noticed. We noticed it with the boot and his thumb. That is the rule. We can say it in those words, or we can just say, as you see right here, my original point changes to, they both switch places, the x and y switch places, and whatever that y was right here turns opposite. That's what that negative means. That negative means opposite. Okay. Give you a second to copy that down. So now let's see what happens when I rotate 180 degrees. Okay. So let's go over here, and let's start with, let me erase this mess. Let's start with this Mario again, like we did before. We'll start with that Mario. And if he rotates 180, that means he goes over here, and then he ends up over here. So that's 180, right? So what do you notice about these 2 points? Very good. Someone in the chat says the 4 and 2 stay in the same place. The x and y stayed in the same place. Don't worry about the sign right now, but the 4 and 2, the x and y values, stayed in the same place. So let's put that. Let's put that. That's part of our rule. For each point, right? Because we got to do this for each point. The whole figure moves. The x and y coordinate stay in the same place. And, okay, now let's look at the signs. Okay, so what happens? So let's look over here. Let's look at these again. We'll go 180 and we go over here. They stay in the same place, but what happened to the signs? Look at the 4. The 4 is positive 4 and it turned to negative 4. The 2 here is negative 2. It changed to positive 2. So what does that mean? What happens to the x value? What happens to the y value? Anybody? Anybody? So we're just looking at this point and this point, right? That's 180 degrees. When I go from this point to this point, the x and y, the 4 and the 2 stayed in the same spot. But what happened to the actual numbers? What happened to the signs? Anybody? Come on, guys. You've got to be paying attention here. What's going on? It's pretty easy to see. Look at this. That's a 4. And when I rotate, it's a -4. That's a -2. Now it's a +2. They didn't switch. The x and y stayed in the same spot. But what happens? Opposite signs, right? They turn opposite. This is called opposite, guys. +4 to -4 are opposites. Okay, you guys got to know that vocabulary. Opposite means signs. If they are opposites, that means they have opposite signs. So they didn't switch, right? When you say switch, that means they switched positions. They didn't do that. They stayed in the same position, but they are now opposite signs. So we're going to say that. See how we said up here changes signs? You see up here it says changes signs. Up here, we're going to say, what's going on here? The x and y coordinates change signs. Okay? So let's think of when you say switch, that means the x and y change position. That didn't happen. But the signs do change. So make sure you say that right vocabulary. When you want to change it from positive to negative or negative to positive, you're changing it to the opposite or you're changing signs. Right? You can say opposite if you want. So let's do that in our shorthand. We can say the original point, xy, changes to, well, the x and y stay in the same spot, but they both turn opposite. So how do we show opposite in math? Put a negative in front of it. That just means opposite. So this is saying every original point changes to, the x and y stay in the same spot, but x turns opposite, y turns opposite. That's what that means. So there's my rule for 180. There's my 180 rule. I'll give you a minute to copy that 180 rule, and then we'll do the 270 rule, and we're done. All right, so I'll give you a minute to copy that. 1. Okay. Now somebody in the chat asked me, Mister, can you verify this? So every time it turns 180, that's what happens? Is this what happens, Mister? Every time I rotate 180 degrees, my point changes to just the opposite signs. The x and y stay in the same spot, but they change the opposite signs. Well, yeah, let's look at it. Let's verify. We have Mario to help us verify. Let's pick his boot right here. 6-3. Okay. 6-3. Let's rotate all the way 90, 180. Now we're over here. Now look what the coordinates are. -6, -3. Exactly like we said. It's exactly like we said. -6, -3. Right? Let's try it here. Let's start here. Let's go 90, 180. Oh, look at that. It went from -2, -4 to +2, +4. It worked again. I don't believe you, mister. Okay, let's look at one more time. -3, +6, 90, 360, +3, -6. The signs just changed. So it's pretty easy. When I'm going 180 degrees, I just keep the points the same. To get the new points, I switch the signs. I'm sorry. I change the signs to the opposite, and I don't switch the x and y. All right, so what happens? Let's do the last one. What happens at 270 degrees? So let's start here. So 270 means I go here, 90, here, 180, and I go one more. Here, 270. So let's look at those. What happens? Uh-oh. The x and y do switch places. But what happens? When I go from here to here, to 270 degrees, they switch places. But what happens? This original x turns opposite now. The original x turns opposite. Not the y anymore. And then this one stays the same. Okay, so let's write this down. Let's do the first part at least. We can do the first part. So we can say for each point, we know the x and y coordinate switch. just like they did for 90 degrees. The X and Y coordinates switch places. And, right, so we know they switch places, so what's the second part? So if we look here, we're doing this, and we go, they switch places, and the original X turns opposite. The original X turns opposite sign. The original Y stays the same. So let's say that. And the original X coordinate changes signs. So how are we going to write that? We'll say XY, original point, moves or changes to the Y and the X switch, so the Y, X, right? And now this original X changes to the opposite. And there you have it, guys. These are our rules that Mario helped us find. These are the rules. No, not Mario in class. Not you, Mario. Mario, Super Mario. You're another Super Mario. But this is, classic Super Mario. Anyway, these are the rules for rotating figures. If I'm going to rotate counterclockwise, this is all counterclockwise. If I'm going to rotate counterclockwise 90, I switch the X and Y, and the original Y, which is the new X, changes to the opposite. If I'm going to rotate 180, doesn't matter clockwise or counterclockwise, 180 gets you to the same place. I keep the X and Y in the same place. I just change both signs. And for 270, I'm going to switch the X and Y again, but this time I'm going to make the X, the original X, the opposite. Okay, so I'll give you a second to copy these, and then we'll do a little example, and then we're done. And it's going to be 1 point. I'm not going to do a whole figure. I'm just going to do 1 point example. Okay, so I'll give you like 30 seconds to copy this, and we're almost done, guys. We're almost done. So again, this chart you don't have to memorize. This chart you don't have to memorize. You can always look at it, but it does make sense. And I would look at these, right? Look at these. This tells you how the points change for each one. Okay, we will continue this on Tuesday. Enjoy your 3-day weekend, guys. Enjoy it. Take care, everybody.